Okay, back on, that was a little less than 8 weeks or 10 weeks of, we're trying to head for that goal. So if we can, the rec machines, as well as looked in that video clip, we have really achieved our goals on this OFTA. That was in Fremantle, we were putting that machine together, and those were just still shots taken over a period of about nearly 2 months as they put this machine together. So again, for the requirements for a successful OFTA, what we try to do is use as many proven prior design components as we can. We're great users of 3D design now, and also trying to put that together with CAD and fit up in the drawing board before we go to machining. We do 100% dimensional inspection of all the key components. That's key using those CMM machines. We go in and check that, hey, we've done things right. And we pre-assemble components. If we think there's any problem with distortion or anything, we do assemble the components. And of course, we're well aware of the risk that these components don't fit up at site. It's a whole big different problem. And that means that we have to, and we have at Robin, stepped up our quality control significantly over the 5 years. Not that we were bad at it before, or with a lot of problems, we had to go to another level, and we've done that. So that's a whole process. Of course, quality control is always an ongoing process. And to make this software successful, very important to do the planning. You got to plan for the parts arrival. You got to have your crews there. You got to have more components than the small fittings and other things that we've learned. You got to have all those there ready, and so it's a question of preparation, both with tools and personnel, and with good procedures, good planning with your team, with the contractors team. And we send out probably twice as many field personnel as we normally would in each case when we do these OFTAs. And I think that this graphically, this illustration here of what happens in a normal process. Every one of us in the CDM manufacturing business now, of course, do very little of our own work in-house. Most of the components are bought outside our own workshops. Most of the machining is done outside our own workshop. A lot of the fabrication is done. And then we pull it together in a workshop. So here we are in our facility in Ohio. Here we'll get components located in the U.S. We'll buy some components in Europe or UK. We'll buy some components in Japan or China. And then we pull them all into our workshop. And what we're showing you here is what happens if we have a project in Rio. So whoops. Okay. Yeah, the arrows are coming in here. And so you can see what happens in a normal process. All the components come into our workshop in Ohio. Then they're all put together, they're disassembled, and we ship to Rio in this case. If we do OFTA, here's what happens. The components come directly from their manufacturing location, and all coming from different sources and heading to the eventual job site. And I think from that process, you can visually see how you get a big freight pig. We got one more poll question here. I think this is the last one. We'll be into the question and answer period fairly soon here. This is about your experience So I'll answer some of these questions later, but I'll field another question, Brianna, as this question is answered.
Another question is, how many other OFTA projects have been done in the industry?
Yeah, there's been lots of forms of OFTA done historically, especially with rebuild machines. I know in our experience at Robbins, we've done this partial assembly before. It hasn't been widely done, but certainly it's been done. I'm not sure about the other manufacturers whether they've done it before or not. I suspect it has been done. It just wasn't named that and wasn't recorded that way. But I think to do it well, you have to have some experience, and you certainly have to pre-plan for it. Okay, we'll take a look at this poll, see what the results are in a minute. All right, guys are slowing down on your computers. I don't see this come up as quickly as the other ones did.
About 5 more seconds there, left.
Okay. Yeah. Yeah, the big question, of course, is accuracy and fit up of components. That's what you'd all expect. That's what the concerns are, that and staying on schedule. So that's pretty much what I would have expected. Those are the questions we always get asked. How are you going to ensure accuracy and fit up? Those are exactly the main question posed when we do this. And hopefully I've shown how we do it, with these CMM machines and CAD drawing. I hope I addressed those concerns adequately. There still is some resistance to this process, and I'm okay with it. I'm okay with the industry still demands shop assembly. I still got several big workshops. Robbins has several big workshops. I like to see them full. I don't like to see them empty. And so I'm okay if it's not totally accepted in the industry. I just see it as a process that's going to occur in our industry, and I want to be able to part of that process. But some of the risks inherent, there's a lot of risk inherent to underground construction, as I've stated many times in some of my speaking engagements. That our industry has to really pick up our game in terms of being reliable and getting our projects done at the cost that we bid them at, and then the time schedule that we said that we do these projects. So it's a process that I understand why there's a resistance to accept this new method. And again, us manufacturers probably not in our best interest, really. We all got workshops, some smaller and some bigger than Robbins workshops, but certainly it will affect the utilization of those workshops. And it's an educational process, too. I'm glad to see a lot of consultants on here today so that we all understand this risk, what the experience with it is. I'm glad to see that, and I understand it's a process, a learning process. And so through these sessions, this webinar and other sessions, we're trying to make people aware of this option. We're not just out here to promote it because it's something that, it's kind of a joke that we hear, hey, why don't promote this because we don't have any workshops? Well, guess what? I'd rather see my workshop full just like everybody else, but I just think it's a good thing for the industry. So, in summary, and then we'll get into questions here. I think it's our responsibility. If we can do something that affects the cost of our projects, that affects the time we can do it in, I think we're obliged to do it. And in my view, it often gives that possibility. So that's really my summary on this. That it's a tool or it's something that can be used that benefits the project, makes our industry more cost effective. And if it does, then I think we've got an obligation to use it. With that, I'm going to open up the session for questions. Thank you very much for going ahead and listening to my presentation here. I really I don't know if I enjoy being on a webinar, but it's been my pleasure to be in front of you tonight, or this morning, wherever it is. And, thank you.
Just as a reminder, if you want to have your question answered, if you type it in, we'll ask the question. Here's another question. Does Robbins provide training of personnel for on-site assembly, or is field service provided?
It's actually all wrapped up into one process this way. You know, we don't, usually when we do OFTA, we don't say, okay, here we've got 20 men included in the price of the machine is 20 man months for assembly and testing. What we usually give you is a cost for the machine assembled at site, including the training of your personnel. It's kind of all wrapped up in one, not separated like it historically does. And certainly we normally stay with the crew until all the debugging is done. You know, in these OFTA and shop assembly machines, there's hardly a machine that goes out of a workshop that doesn't have a list of 15 or 20 things to do, or even longer or less, and when it gets to site, because there's always a rush to finish up the testing, get it to site, and okay, we'll take care of that at site list. That list occurs in every machine with every manufacturer, and it certainly occurs in OFTA. After we start to bore, there's still a hit list of 15 or 20 things to do that we do as the boring or the learning curve processes. I think that answers that question.
Okay. Have there ever been any quality issues with OFTA machines that were linked to poor TBM performance, such as settlement or cutter head wear?
No, there hasn't. Certainly we've had some problems during fit-up. That has occurred, and we've been able to correct them in a very short period of time. But as far as once we got the machine together, did it work, or was there any inefficiencies because we used the OFTA process? I think I can categorically say no. Once we've got them working, there was nothing that has been OFTA related that has affected the performance of the machine. And that's the reason why. I mean, you put the machine together. If you have these settlement or wear problems, it's usually a design problem. It's not a mechanical fit-up problem.
Okay, another question along the same lines. What does Robbins do in the unfortunate case of one complicated piece of the TBM being off tolerance when installed using OFTA?
Yes, we know that happens, and it has happened to us. We've had to do remachining. In the world today, there's all sorts of machining tools that go out and have portable machining devices that you can bring on the site. So if we think there's a problem or there's going to be a problem, we know where these tools are. We know where the people that have these tools, the experienced companies that do them. There's in various parts of the world. So we make sure that we know where they are, who's got them, and if we need them, we can bring them to site. And in one case, we've set us back probably a week. That we had a fit-up problem that we didn't pick up. This was early on in the process of OFTA, and we had to bring in these tools and do some remachining. And as I said, it set us back probably 10 days. Okay.
Another question, for a 12-foot EPP machine, what is the size laydown needed to assemble the machine on site?
12 foot or 12 meters? 12 foot on entry. Okay, well, 12 foot, the laydown area is probably something, if we can talk in feet, something around, usually we like to multiply by 3, and for the width, so that we're looking at about 35 feet for the width, and then usually about 150 feet long in this case. That's the ideal laydown case. In a lot of cases, you can't get that, and we understand that. So we do staging as I showed you in the slide on that EPV. I mean, on that ping arrangement, what you try to do then is get a staging area. And then go into the staging area, then